Good morning, everybody. How's everybody doing? Good? Yeah. No worries. I have a few slides, but then we'll do stuff live. So let's see how that goes. So it's a bit about monitoring all the things. That's kind of the topic of my talk. So the idea to this talk, I got kind of when I saw this tweet. Who doesn't like murder mysteries, but maybe not in IT? Because as soon as you have like this distributed system, finding out stuff is kind of getting harder and harder. Like you have some little traces here and there, and stuff just gets more complicated. And I guess a lot of you will see themselves a bit in this picture. You don't have to raise your hand if this is you. We can keep this anonymous. And you still say, well, this is fine, at least for now. And at some point, you will figure out this is no longer fine. Like, everything is burning, everything is crap. That's not what we want to have. And the idea is kind of like to figure out that stuff is going so wrong before we get to this point. And the final thing, final tweet, no worries, is once you have like a distributed system, the things you really want to have is you want to have something like centralized logging, that you have this single point of seeing what is going on. Because SSH and tail is fun on one single server, but as soon as you have 20 windows open to see what is going on all of them, SSH and tail is not that great anymore. And the second thing is you want to correlate IDs across calls. We'll see that at the very end of this talk. So kind of the idea here is to log and monitor all the things. And well, since I'm from Elastic, we'll use the Elastic Stack to do that, and we'll jump right into that. Why am I talking about that? Well, we have the products. I'm a developer advocate, so I do a lot of conferences like 4 this week, which is a bit much, but yeah. I'm just jumping around trying to show off the good stuff that we have. So this is a Hello World application. It's nothing too fancy, but I'm trying to not cheat too much. So it's using proper certificates, and it's trying to do the right thing so you get the idea of what is going on. You can get all the code afterwards. I'll have the link at the end again, so you can just check out what is going on, and if you think it's interesting, you can get the code at the end as well. No worries, but yes, you can take a picture now as well. So I'll build a very simple application. I'm using Java, but it doesn't really matter. It's like any application that is just calling other stuff in a system. It's simple. There is no load balancing, auto-discovery. Like, I'm not doing any fancy microservices patterns. I'm just sticking more to this definition. As long as the API names are short, it's also kind of a microservice. So if your boss asks you, are you doing microservices? This is the simple solution, which you can just apply and say, yeah, we're doing something micro, whatever. And of course, I'm running this in the cloud, so I'm using the cheap AWS instances, the Lightsail ones. I have provisioned everything with Terraform and deployed and configured my instances with Ansible. If you're interested in that, come talk to me afterwards to check out the repository. All the code is there, but I don't want to dive too much into that. And well, we have our own cloud service to run Elasticsearch and Kibana. Since I'm lazy and didn't want to set that up myself, I'll run everything off of that. And that's pretty much the setup we have. And all the stuff I'm showing now is open source, so you can just freely use that, change it, do whatever you want with that. So that's the idea. And this is generally our stack. I'm just using 3 of the components today. So we have beats sitting kind of at the bottom. These are like the lightweight agents or shippers that we have. Like, these collect information and will send that out. And basically, they send that information to Elasticsearch, which is storing our data. And on top of that, we have Kibana to visualize what is going on. Logstash is not going away, don't worry, but it's not really required for the use case I have here. Logstash is more of an integration layer. Like, you want to get data from various sources, you want to parse it, enrich it, and send it somewhere else. That is what Logstash is for, and it's not going away. But today, I'm just collecting some logs and metrics from a few nodes, and we'll forward them directly to Elasticsearch. So we'll just do beats, Elasticsearch, and Kibana today. With that, let's try to jump into the demo. And let's hope the demo gods are with us today. You never know. Finding my right window. I guess that is readable for everybody, right? OK, so if you've never seen it, this is Kibana. This is the current version, 6.2. And just to give you a quick overview of what is going on, we have this monitoring component, and the monitoring component, by the way, just shows you what is going on. So I have one Elasticsearch instance, so it's a single node. I have one Kibana instance, it's also a single instance, and then I have 3 nodes which I'm monitoring, and I have rolled out the various beats to them to collect information. So you can see I have audit beat. Audit beat is basically collecting security information. It's like kernel events or something changed on your file system. So you can monitor, why am I suddenly serving malware? Because at some point, some file was changed, and then you can figure out why that happened. Then we have metric beat, which is like top to collect system metrics, but it can also get application metrics for you. Then we have packet beat, which is a lot like Wireshark. It's just Wireshark is nice on a single node, but as soon as you're in a distributed system, running Wireshark is kind of a pain, because then you need to run it everywhere, collect and combine those captures, and then see what is going on. Packet beat is kind of like doing that for you and just collects the information and parses the headers and just shows you what is going on. Then we have file beat, which is collecting our log files. And then I have, on a single of my 3 instances, I have Heartbeat running. Heartbeat is basically a pinger. So it's just pinging my service and checking, is it still up, and is it responding in a reasonable time? And now that we're warmed up, I guess I can take off my hoodie before we really dive into it. So let's see what is going on my instance. So since I'm lazy, I didn't build all of that myself. I've mainly imported the pre-built dashboards that we have. So the beats, you can see audit beat has these dashboards, file beat. These are just the dashboards that I have imported and that you can just use. And just to get a feeling of what my system is doing, I will start off with metric beat and the system overview. And the system overview is basically showing me what do I have here. So you can see I have 3 instances, a backend, a frontend, and a monitoring instance. You can see CPU, memory, disk usage is all very low. Everything seems to be pretty much stable. You can see CPU usage, which is also very flat, basically. And you could dive into a single instance. So for example, I could dive into the monitoring instance. You can see up here, I have limited down to the monitoring instance, and you can see how much information we're collecting. So you can see CPU usage, memory usage, that all looks pretty well. You can see network traffic and just which processes are running on our node. If I want to slightly change that here, I could say I want to put a star here, and then it will show me the information over all the instances. And something funny is that we have these little spikes here. So you can see our memory usage is pretty flat in general, but every now and then, like every 5 minutes or so, we have some weird spike there. That is the red area here. And we have here, we have these little spikes, or here. And maybe we want to figure out what is going on. So metric beat is collecting that system information, and now I could build a custom visualization to just see what the system is doing in detail. To build a new visualization, these are all the ones I have imported already, but we can just build a new one. So here, these are all the visualizations you can build. One of the newer ones I want to use now is the so-called visual builder. The visual builder is basically taking time series data and just giving you lots of options to graph those out. And what that looks like is, by default, you can see here, these are the number of documents we have inserted. So we're pretty much getting 300 or 400 events every 10 seconds. And now I want to switch that not from the file beat, because these are the log files we're collecting. I want to switch that to the metric beat, so the metrics that we're collecting. Metric. Let me type that again. Metric beat. Yeah, that's what I want. So we have like 200 metrics every 10 seconds. And now we can actually not show just the number of documents, but we can say, I want to get the memory usage per system. And I want to say here, I want to have the sum of all the processes running here. So you have system dot memory, system dot memory. You see, we support Kubernetes as well, but today, no Kubernetes. I'm just interested in system memory actually used bytes. And here, I can say, this is actually not a number, but these are bytes. And if you switch that to bytes, it will actually show you OK. On average, we're using like 1.7 gigs of memory, but here at these spikes, we're using 2.1 gigs. And this is just the overall view. So the first thing I might want to do now here is I want to group that. And I want to group that by my host name. And the host name I have in a field called beat.name. And you can see everything is pretty flat, like I have my 3 systems here. Just this one here is spiking. It's just one of them. It's the front-end instance. So generally, it's flat around, I don't know, close to 600 megs. But here, it's spiking up to nearly a gigabyte. So something is wrong there. And then you could figure out, like, which process might it be. We can call this memory per process. Let's say we make this red, just to make a differentiation. And here, I want to have the sum. And I think the field should be called system process.memory RSS bytes. So this is the sum of all the processes. Once again, I say this is bytes, so it's kind of like nicer and more readable. And then I say I want to group that again, and we have a field called process.name. And I say I want to see the top 15 processes that I have in my list. And then you can see, yeah, there is a correlation between there is some process that is using a lot of memory, but every now and then the process is spiking, and that is exactly the one with that spike here, and that is a Java process. And then you can dive in and see, like, why is Java doing that? If you don't like this view, actually this is pipeline, so you can do another step on this one. So what you could do is you could say, I want to put this on the negative y-axis. So what I will call this here is, this is just a variable name, and then I can say params.process. This is the variable that I have defined here. This process is the same process here. I calculated time -1. And then I have it on a different axis. So you can see here, I see this is my front-end instance, there's a spike. This is my Java process, which is generally already taking up most of the memory on my system. But here you can see there is a clear Java spike. And basically what I'm doing, I have a cron job that is running every 5 minutes. That's running the typical Java program. And the typical Java program is just allocating memory until it runs into an out-of-memory exception. So this is basically what every 5 minutes is happening here. This is just the system view. So now let's see what our application is actually up to. And for that, I need some requests. So I assume most of you have some mobile phone or laptop out. Can you give me some hits on that address? There are some links, you just need to click those, and we'll actually collect that information. So you just hit that, and then I'll try to see what you're up to. So the page you are getting should look like this. By the way, did anybody figure out how I got to that URL? I mean, WTF is kind of obvious. That's also the right URL for a demo, I think. But did anybody figure out the Xera thing? This is just like, it has something to do with my name. Can anybody see the connection between my name and that it's also my Twitter handle? Is there something to do with my last name? It's the good old rot13 when you rotate the letters by 13, so you go from A, B, C, whatever, you continue 13, and that is when you take my last name, and that is what you get out of that. And if you rotate by 13 again, you're getting back to the original. That's kind of like why rot13 was kind of in the good old days of Usenet very widely used. Okay, so this is the page that we have, and you can either get a 200, which should just give you a hello world. You can get the same thing with a parameter, and you can change that parameter in the URL. If you add your own name here and do enough requests, we will see that in the logs afterwards. Because I'm logging all the parameters that you're hitting. And you can also get a 400 or various 500s. It's just like your average application that is doing some good stuff, some bad stuff, and we want to see what is actually going on. OK. So the first layer, or the first thing I want to take a look at here is the network information. So we have PacketBeat for that. PacketBeat can give you an overview of what is going on in your system. So we're, like I said, we're parsing the network headers, and we're, for example, see here that suddenly we had more HTTP requests. Like, we didn't have any HTTP requests before, more HTTP requests now. I don't have a database or a cache right now, so you don't see those. But you can also see, like, before, the requests to my system were pretty stable. That's kind of like the height of these bars. And the colors tell you how long did the requests take. So you can see up to 10 milliseconds is this yellowish, brownish, whatever color. And the longer they take, they will have different colors. And you can see like some of you had to wait like 100 or 180 milliseconds or something like that. You can also see percentiles. Like before, you did the requests, the percentiles and the response rates were pretty fast. But at this point here, you saw the 99th percentile already rose to like something 700 milliseconds or so. So yeah, we got more traffic, so the latency is also changing. These two colors are very hard to differentiate, so let's switch OK to green. And we had one single error up here, I think. So luckily, our system didn't have lots of errors, but we did have like 3 TLS errors overall. And you can see here, this is the latency histogram, like 1,400 requests were very fast, but somebody was unlucky and had to wait 1.1 second for their request to being served. So you can see what is going on. And PacketBeat is basically doing the same what is Wireshark doing. So it's just parsing the network headers, and it then knows, OK, the request that came in was HTTP. You requested the URL foobar. You got that after 100 milliseconds, and the response code you got was a 404. And this is basically what PacketBeat is doing. You can also see the flows. Flows is basically TCP IP connection. And you can see suddenly our connections kind of spiked here, which is good. This is what we wanted to see. Did anybody write a script to just continuously ping the page? Because I've had people do that, and I think we can serve, I think we can serve something like 10,000 requests per second. The nodes, something like that. Normally, the network is the limiting factor because, well, the page is very simple. And you can see which IP address is communicated with who. Now, we could look at the web transactions, but the web transactions won't show us much because the traffic is encrypted. And we cannot see into the encrypted traffic. Since you might have noticed, or on the mobile phone it's probably hard, all your requests were against HTTPS. But we have the same information somewhere else. We have it in the Nginx access log. And let's quickly check those out. So I have a reverse proxy, which is Nginx var log, Nginx access log, and Nginx access logs. And you can see, for example, here, Lucas did a request. And we have a lot of meaningful information here. So you can see stuff like an IP address, a date, a timestamp. You see the HTTP verb, which was get. Then it was the URL good from Lucas. You can see he got back at 286 bytes were sent. And you can see the user agent. Obviously, this is an iPhone. And we have all of this information here. The kind of like the old approach to do that was you would configure Logstash to pick up that file, and yeah, Apache Bench is also very active here. So you would basically tell Logstash to collect that file, and then you would define a regular expression how to parse that. However, at some point we figured out, well, a lot of people are doing the same thing and are adding the same rules. So we have to FileBeat, which is collecting log files, we have added the so-called modules. And for example, we have a MySQL, but also an Nginx module. And the Nginx module basically knows on your operating system, which is Ubuntu in that case, the access log for Nginx is under var log Nginx access log, and it has this specific pattern. And it just does all the magic for you and parses out that information automatically. And then it has a dashboard as well, and we can take a look at the dashboard. So these are all the file beats that we're supporting. Let's go to the Nginx overview. You can see we got some geo-IP information. Basically, we're taking the IP address and doing a geo-IP lookup. That information might be good or it might not be good. That is always a surprise. So let's try to figure out how good our IP information is today. You can see some IP addresses have been misqualified to come out of Paris, but most of them are from Spain. So most of them assume it's just Madrid, which is kind of unfortunate. But there were some, I think some were classified as Madrid as well, but it was very few. So I don't know if whoever is running Apache AB, if you're on the hood, on the conference Wi-Fi or on your mobile network, the Wi-Fi, okay, then obviously the IP address of the Wi-Fi seems to think it's in Madrid. That's kind of like the quality of geo-IP lookups. It's always kind of like you're never sure what you will get. And this is actually where we can see how many requests we're doing. So we can see, okay, here we're doing 1,000 something. And at first it was mostly 200s, but now people started to ping more the 400 pages. So something is going wrong here. You can see, okay, hello Rafal is kind of like the most requested URL right now. I want pizza is number 2. But you're still a very good audience. Like I had much worse in there. Like sometimes I have really bad words in there. Once somebody tried to push some advertising, and what people sometimes also try is to do a script injection. Like they do a script alert 1, but we do escape that, so it doesn't work. You can try, but I won't have any pop-ups coming up in Kibana. We do escape that. You can see how much traffic we're serving, so it's not even 1 megabit. But we can also see which operating systems people are using. So for example, we see iOS, which is this one, I think. iOS, and most of you have already upgraded to version 11. That is 85% of you have upgraded to 11, but somebody is still on 10. So 15% are still coming from 10. And I can see, obviously, this is a desktop. I'm kind of sad that there is no Windows Mobile, because sometimes you have 1 or 2 people using that as well, but unfortunately not today. And you can see, okay, wget is kind of popular, Chrome, mobile Chrome. So you can see the breakdown of what is going on. So this is the system that we're monitoring. And we're just parsing that out of the logs, so you don't need to do any instrumentation of your application. Also the same for PacketBeat. We're just parsing that out from the logs. And that's kind of like magically happening for you. The next thing that we might be interested in is if you get this 500, like what is happening in my system? I'm throwing some very simple errors here. I'm basically throwing an out pointer exception and the runtime exception, but just to get something that is going wrong. And how would you normally do that? You could write your logs, var log, I think I've called it apps. This is the front-end app, and there is log. And here, for example, you can see, nice null pointer exception. You can see a timestamp again. You can see the severity. You can see which classes were called. You can see the servlet, where it happened, and what the error was. Now, you could, again, write a regular expression to parse that out. But since I'm lazy and I don't enjoy writing regular expressions, I didn't do that. I kind of cheat. I have a different log appender that is actually writing out the same information as JSON. So if you write that out in JSON, and is that the same? I think this is it's probably this is the same error message. So here, since it's in a structured format, we don't need to do any parsing and any regular expressions afterwards again. So since Elasticsearch stores JSON, FileBeat can just collect that JSON file and forward it directly into Elasticsearch, and I don't need to do any parsing. And that's exactly what we have done here. And we can actually see that in the Discover view. So here, you can see FileBeat has collected in the last 15 minutes, we collected 80,000 log events. This includes both the system logs and the Nginx access logs, but also the logs from my Java application. And I've actually tagged my Java application correctly. Just to give you an idea what we've done here with FileBeat. Sudo vi etc FileBeat, FileBeat YAML. So what I've done here, basically, I say is, this is the place where I expect my log file. It's a JSON file. So just collect that JSON file. And I know this is a Java application, so I'm telling that explicitly you are a Java application. I'm also running the Nginx module and various other FileBeat modules to collect information automatically. I'm tagging my instance with a nice name. I say this is a production instance. It's running Lightsail. I'm adding some meta information, and basically I collect all of this information and forward it. So what you can then do is I want to filter that down to my Java application. So here I say application is Java. That's kind of like the obvious one. And suddenly, out of my 80,000 log events, only 30,000 are from my Java application. And then here we have the different JSON fields we have collected. So the one I'm interested in now is the JSON severity. And you can see, OK, somebody did a lot of errors, and we have very few infos. Normally, it's kind of the other way around. But fair enough. Now I'm interested in the errors. So I can just filter down on the errors. So I click on that little plus magnifying glass here, and you can see out of all my messages I've collected, 13,000 were errors. And then you can open this one, and you can see, okay, this is what I've just collected. This has come from the front-end instance. It was an error. You can see what is going on. So I had a null pointer exception here, and I've also enriched it with some cloud information. So I see this is the ID of my AWS instance. You can see I'm running in Dublin. It's the A region there. I'm using a T2 micro instance. So you kind of like find it also in the AWS console and see what is going on with your instance. The other thing that might be interesting is this stack hash. Basically, I'm taking every single stack trace, throw out the stuff that is changing between requests, and hash that. So I can uniquely identify one specific stack trace. And then we could graph out how many different errors are we even having in our system. So I'm building another visualization. Are you okay with a vertical bar chart? Let's try the vertical bar chart. Oops, no, that's not what I wanted. Back. Vertical bar chart, I want to use file beat. And what I'm interested in, I want to split this up on the x-axis. I'm looking for a specific term. And the term I'm interested in is called JSON stack hash. And let's say I want to get the top 15 stack traces I have in my system. And you can see this was the most common stack trace or stack hash that we had. So this is the error you probably want to fix first, because out of all your errors, this was the one that happened most of the times. And then you might want to find this one, and then you might want to dive into this one. You could even break this down and see, for example, how many users were affected. So again, I'm going for a term, and in a term I'm saying JSON.name. So if you specified a name when you did the request, you can see I want pizza or whoever was affected by these errors. Right now we're just doing the top 5 users, let's say, broken down by the top 15 users. Thanks for all the interaction, and everybody has added something. I hope you can find yourself in the errors here. And yeah, somebody was very active in pinging some error page, and I will fix your errors soon, so you won't run into that anytime soon anymore. So you can see what is kind of going on our system here. By the way, did anybody try to log in via SSH into the instance? I'm just curious. Because we can monitor that as well. And no worries if nobody did, because normally the Russians tried. Okay, obviously you didn't try, but this instance has been running for a few days. So let's say I want the last 7 days. And in the last 7 days, okay, on this day I started the instance, but you can see we had some accepted logins. So this was when I set up my instance. Something was invalid here. And this is actually, we had login errors. So these were the successful ones. And down here, we can see the unsuccessful login attempts. And if we zoom out a little, no, China is leading today. So you can see that the red dot here, China has done like 109 attempts to get in. Whereas Europe and also Russia was not that active anymore. And we can see somebody also tried from Spain now. So what you can do then is, here you can see all the usernames that people tried which failed. And we might be interested in to see like what did people from Spain actually try out. So I can actually filter that down here as well. So this will be very coarse-grained. So let's say here, this is kind of the border of Spain. I hope this is good enough. What this does is it applies the filter on the geo points that I've given here, and it will just show you which were the login users that people tried from Spain. Yeah, I guess some of you will find their username in there now as well. It's just interesting to see what people are kind of like trying and which usernames might be popular in an area. And down here you can actually see the list of who tried, from what IP, and what was the result. And most of those were just invalid. So this is nice to see what is happening to your instances. Next up, you might be interested in, is my service still up? Because somebody is running maybe a denial of service attack against my service. So let's see if it's still up. For that, we have Heartbeat. And Heartbeat here You can see in the beginning, this was the 7 days I hadn't deployed my application yet. Let's switch that out to the last 15 minutes again, because 7 days might not be that relevant. So you can see some system was down here, or it appeared down here, but right now everything is responsive. So you can see I'm pinging all these instances. The one thing that doesn't make too much sense here, this is my Elasticsearch instance. So basically, I'm pinging my Elasticsearch instance and storing the result in the same instance. So if Elasticsearch is down, you won't be able to store that anywhere. In production, please use an external system where to store that, and not store it in the system you're actually monitoring. And you can see down here, you can see the breakdown, what were the response times. And these are actually broken down in how long did it take to resolve the DNS entry, to establish the TCP connection, to establish the HTTP connection, and the TLS handshake. So you can actually see what is the time to establish the connection and where are you spending it, and what is currently taking longer or shorter here. And then we can actually kill an application. So should I kill Nginx, the reverse proxy, or should I kill the Java application? Let's kill the Java application. Service, it's called front end, and I'm just stopping that one. So now it makes sense we can enable auto refresh, so this will refresh every 5 seconds, and soon you should see something is down here. Anybody knows what the response code will be when I take away the application behind the reverse proxy? Sorry? Yes, 502, bad proxy, or bad gateway. So if I'm hitting that now, yeah, you get the bad gateway. This is the result we were expecting, and you can also see something is down here. And this is actually telling me something is down, and it's telling me that the return code is a 502. So this is exactly what I'm interested in. If I click on that one, it will actually filter down on the one instance that is down, and you can see here, that is my instance that is not being reachable anymore. If I restart that, this will take a little now, because I think my Java application takes about 20 seconds or so to start up. The pinger is running every 10 seconds, and my dashboard refreshes every 5 seconds. So it might take, I don't know, 40 seconds or something like that until this will get or go up again. The down should then disappear, so let's remove that. And soon here, if we're lucky, that red area should disappear again when our service gets up again. So let's see. No, it's not here yet. Let's hope my Java application makes it. Come on, Java. This is the demo effect now. Come on. Did I? Ah, yeah. Now it's taking a long time, so now it's coming up. OK, my Java application is back. My pinger will figure that out soon now. And then my dashboard will also refresh, so it will probably take 5 or 10 more seconds. And then this should go green again. Come on. No, still not. One more. OK, I'll let this sit here. We'll continue with something else. The endpoint that I've pinged was health. I'm not sure if you've seen that, but since I'm using Spring Boot, it exposes 2 endpoints automatically for you. One of them is /health, which actually shows you, OK, my system is up, and this is the disk space. And the other thing it exposes are metrics. Metrics are very relevant. For example, you can see stuff like garbage collection, or how much heap you have allocated for your system, and what your response times are, and how many requests you have served since the node has been up. So you might want to collect that information. By the way, let's see, is my system, yeah, I think it's more or less up now again. Yeah, it's going down, so it should be marked as up any moment again now. OK, so these metrics might be very relevant. And we have, with metric beat, we have 2 possibilities to collect these metrics. One, we have a pinger that will collect a REST endpoint. So we can basically say, this is the URL. Just collect it. Since it's JSON, just store that JSON in Elasticsearch, and I want to graph it out afterwards. The alternative is, since I'm using Java, for Java monitoring, JMX is very widely used. And we can also collect from a JMX endpoint. So since I've shown you the REST endpoint here, I will graph out something with JMX now. So I will build another visualization. Let's say we have the visual builder here. And what I'm interested in now is I'm interested in the metrics, metric beat. What I'm interested in now is the sum of the heap, or actually let's call this heap. So again, I say I want the sum, and the field I'm interested in, so that the library which we use to collect the JMX information is called Jolokia metrics memory heap usage used. That sounds good. Let's say again, this is not a number, but this is bytes. So you can see, okay, stuff is happening. I want to break this down on a per process level again. So let's say the term I'm interested in is the beat.name. And then you can see typical Java garbage collection, like stuff is happening, garbage collection happens, stuff is falling down. Here, the green app is not shown. That was when I stopped my Java application. Obviously, I didn't have a heap then, so you can see that was the Java application, and somebody is still running the pinger. That's why that application is behaving a bit more erratically than my other applications. The one thing, and I need to cheat now, I haven't copied that out before. The one thing, let's deploy something, I need this. I'm using Ansible to deploy something to my application. So this bad jar, this is causing these memory spikes, and I'm obviously in the wrong folder. This is the one I want. I'm basically deploying that with Ansible now. And what is Ansible doing here is basically it's doing its job, and at the end it's writing out an event. Because what you often have, or maybe you know the situation, like something in your system changed, and you're running around the office and shout, who changed something, or who did something, because the application is not behaving correctly anymore. Or suddenly we have a spike in 400s or 500s. And to avoid this, at the very end, what I'm doing here, this is actually the last line that I'm showing here, is I'm storing an event in Elasticsearch. So basically, I'm storing an event every time I change something in my system. Since I only change stuff through automation, every time I touch the system, it will write out an event. And we can actually annotate our graphs. So you can see here we have this field annotations, and I can say I want to get something. I'm storing that in the index events, and the fields I'm interested in are application, user, host. And then I can say user, deployed application, to host. And you could say this is not a tag, but I don't know. Let's say this is a bug. And then you can hover over that, and it will actually tell you, Philipp deployed deploy bad to the frontend instance. And you could annotate all your graphs with this information, whatever makes sense in them, just to see who did what when, and what happened afterwards. And you don't need to run around the office anymore to shout like, who did what. OK, final thing, tracing. Since this is the call is going across multiple nodes, you sometimes have a hard time figuring out why stuff is not behaving the way it should behave. Or your users are coming to you and say, this is slow. And this is one of the worst things people can say, like this is slow, because this doesn't give you many hints of what is going on. I'm using a tracing tool, which I run on the monitoring instance. This is Zipkin. You can tell by the look of it, Zipkin has been developed by backend developers. But it's doing its job. So for example, if I go back to my instance here, and I get a slow 500. So you can see we're loading this, and it takes some time, it takes some time. The slow 500 is not happening, but at some point, it will give me back a 500. And whoever is pinging my system is really taking a toll on it now, because I think it's about to die. We'll see at the end how many requests we got through that. So here, in the tracing view, we can actually see the slowest request. So you can see this request here had 2 elements basically in it, and it took 7 seconds. So that was pretty bad. So let's dive into that one. Actually, just to give you a hint of, I want pizza. of what this is doing in general. So we're annotating our events with additional information. It might be hard to see, but we can have this front end, and then we have these two hash-like looking thingies. So what we have is the application name is obviously the application, how I called it. The trace ID is whenever you do a call against your system, you will generate, the first time you hit the system, you will generate the trace ID, and it stays the same as it does all the calls throughout the system. And then the span ID is basically the method call. So you can see which call inside of your system is taking out how much time. And then we're sending that to Zipkin, where we can actually show what is going on. And I Want Pizza was unfortunately very slow, and it gave you a 400 back. But you see, this call was mainly waiting here. Let's go back. Maybe we can find a better one. I need something with... OK, let's do another bad call. Let's see. Where did my bad call go? Uh-oh. I think we killed the Java application. OK. Do we have anything more meaningful here? No, it was I Want Pizza. So anyway, you see that the call to I Want Pizza took a very long time, but then it called this other thing, which is in this case, unfortunately, called I Want Pizza 2, since we don't have a proper method to handle that. And this is where you spend all your time, and this is where you spend very little time. So normally, you have all these swim lanes where you can see which calls were done and where did you actually spend your time. So this call here is where you spend all your time, and this one here is where you spend very little time. Yeah, and I'm not getting a better example right now, which is kind of unfortunate. Let's see, the last 30. And you can see these calls are getting very long, like my server is about to die because these are already taking like 20 or 15 seconds and are about to hit the timeout. But at least you see how long it took and which instances were affected by those. But I think those were all very slow 400s now. Anyway, that is tracing. So the other nice thing is this also has a Chrome integration. So if you run this page, there is a Sipkin integration here, which basically links to my Sipkin instance. And whenever I call this page, it gives me the ID here, and I can basically link down to that ID. And I think my server is not keeping up with the requests anymore because we're doing too many requests right now. But in like 30 seconds or so, that span should have been analyzed and should be available here, hopefully, if my server or if my node is still able to send those out and is not dying completely. Somebody is killing my node. I'm curious now. I'm just curious. Yeah, OK. This is the instance, actually. OK, memory-wise, we're doing not really OK anymore. You can see free memory is kind of like falling very low. We started the process now, it's better again. But also traffic-wise, now we're serving proper traffic. It's like nearly 3 Mbit we're doing. But I think my node is really dying now. Anyway, that was a nice experiment to see what is going on there. To wrap up, stuff I haven't really covered. One of the things that I didn't show was alerting. You can do alerting. For example, here we're showing the heap. Or here, I'm basically I'm getting the maximum heap usage per node. So this is, for example, the front-end instance. And I want to get an alert if it is above a certain threshold. This is one of the commercial extensions we have, but it's also included in our cloud offering. So if you want to get alerting out of that, that is the way to do. And the other thing we have added recently is machine learning, which machine learning is unfortunately a terribly overloaded term. So we always say it's anomaly detection of time series data. What it basically does is it learns what is normal. So you can see my actual traffic is this blue line. And then it kind of learns, the system learns what is normal. This is like this blue area here. And here, we have an anomaly. Because, well, we were expecting traffic up here, but the traffic fell down here. Anybody remembered what happened on that day last year? There was a big outage. Maybe somebody was affected. Yeah, Amazon S3 died, and unfortunately, this is from our own website. And we had a dependency on our own website to that, and it went down there, unfortunately, as well, and our downloads and everything as well. But since the entire internet was down, nobody really cared. So it was okay. If you're on AWS S3 and they're down, everybody else is down as well, so no worries. But yeah, this is the way to figure it out. So the system learns what is kind of expected, and it will tell you then, okay, this is like something that I haven't seen, and this is very out of the ordinary. Okay, stuff that we will add in the future. We have recently acquired an APM company, so the application performance monitoring. This is an example from JavaScript. And you can see the calls here. So for example, app.js was called, coffee list component was called, and this dispatch coffee here. And you can actually see this was, if you link it down to GitHub, this was the code behind that call. And you can even see who committed that code. So these two people committed that code, and if something is very slow or broken, you know where to complain. So this is basically, we're still in the process of integrating that. We have released the Java agent as alpha yesterday. I didn't manage to integrate that overnight. We have Node, Python, Ruby, Go, .NET will be next. We have those already. So we're kind of trying to get more into the application now to get insights in the application as well. To wrap up, I always say this is a bit like Lego, our stack, because you can build all the things you want. It just requires some assembly. So I've just put some of the options together, but you can totally do different stuff or just the same and add like business metrics, for example. You might want to add like how many things did we sell on our website and correlate that to the performance or outages or whatever comes to your mind. So it's just like you have these building blocks and you can put them together to get data out of that. But you need some assembly, unfortunately. Or this is a feature of open source. These are all the things that we've seen. I don't think we need to go through them. If you want the code, this is where the code is. If you want to play around with the dashboards are living up on kibana.xera.wtf. So you cannot delete any data, you cannot change anything or create new visualizations. But to play around with the dashboards, you can go there and use those. And I hope my Java service is not dying in the meantime. With that, I guess we're pretty much out of time. If you have any questions, I'll be at the booth outside. Just around the corner. I guess you've already spoken to my colleagues. If you have any questions, just come to me and ask. And yeah, we have stickers and everything outside, so come to us. Thanks. And I'm always taking a picture with you.
We can do one or two if you want.
OK, wait. Smile, everybody. Because my colleagues normally don't know where I am. So I need to prove that I've been working today. OK, we can do questions. OK,
yeah,
any questions?
We can do one or two quick ones before we go to a coffee break, if someone wants to. And
yes. Anybody dares? Yes, please.
Thank you. I have one question about the alerts. If I want to get notifications about some values, for example, on my phone or email. So do you have something like that?
Yes. Like I said, unfortunately, we're a big company by now. We are all more than 800, so we need to pay the salaries somehow. And alerting is one of the commercial things where we make the money. We call it Watcher, since it watches stuff. Basically, you define a query for Elasticsearch. So anything you have in there and you can query, you can act on as an alert. And then we have integrations for PagerDuty, that would be the call or whatever, Slack, HipChat, webhook, email. I think you can automatically create a Jira ticket now because somebody wanted that. I don't know how many tickets they got by now, but somebody really needed that feature. But this is generally totally possible. So you can, both on a text level, just with the query, or in the visual way, you can create thresholds and then be alerted. Or for example, you can combine that with the machine learning and say, if I have an anomaly with a certain severity, I want to be alerted as well, because something out of the ordinary is happening in my system.
Is there a limit? For example, it can check every second, or
yes. it's basically interval-based, so you say check this every minute, every 10 seconds, every 5 seconds, whatever. This is just up to the resources of the node doing the alerting then. But yes, you can run the query every 1 second. The 1 second might be a bit fine-grained. But you can totally do that. But if something goes wrong and you check every second, you might get a lot of alerts.
Thank you.
Just a final one if you want
Yes,
to. And then,
final.
oh yeah, there's someone up there. Yeah.
Hello, thank you. I have a question about alerting again. I understand it's XPack and it's a... Yeah, okay, sorry. I understand it's a commercial feature, of course, but let's say I would like to replace Itinga or Nagios instance only with this stack. What percentage of all the functions that Itinga gives you, like dependencies and notifications, escalations, are already implemented? How good is this stack to replace Itinga?
I'm unfortunately not that familiar with Itinga, so if you give me features, we can do that afterwards.
Okay.
If you show me the features, like, can you do this and this, I can say yes or no, but I don't have like the total overview in my head, unfortunately.
Okay, sure.
Since I don't know the product that well. But come to the booth and we're happy to discuss that.
I will. Thank you. Thank you very much.
Yeah, and for any other questions, just come to the booth as well. We're happy to answer. Thanks so much.